Welcome to Ask and Learn.
Okay, so this problem states that a certain figure shows a PV diagram for an ideal gas in which its absolute temperature at B is 1/4 its absolute temperature at A. What volume does the gas occupy at point B? How many joules of work is done on the gas in this process? Was it done on or by the gas? And did the internal energy of the gas increase or decrease from A to B? How do you know? Did heat enter or leave the gas from A to B? How do you know? Okay, so starting with A, so actually maybe I should go ahead and draw this PV diagram since I'm going to be referring to it. So I'll start by doing that. Okay, so here's my p-axis and my v-axis. And then its units are liters and atmospheres. So neither of those are SI. There's so we'll need to remember to convert. And so this all occurs at a pressure of 1.5 atmosphere, and we're going from A to B. And at A, we're at a 1/2 liter. Okay, and then and then we also know that T at B equals 0.25 T at A. Okay, so first we're asked to find the volume of gas at point B. So to do that, we want to invoke the ideal gas law, which states that PV equals nRT, and then rearranging that to solve for volume, you can get that V equals nRT divided by P. So just dividing both sides by P. And here we can see what happens to volume if we change the temperature. So if the temperature is multiplied by 0.25, and everything else stays the same, and R and P, then we know that the volume is going to get multiplied by 0.25 as well. So the volume at B is then equal to 0.25 of a 1/2 liter. And so let's see. So that's 0.125 liters. Great. So now we know what the volume is, 0.125 liters. So I'll go ahead and label that. So now on to the next question. How many joules of work was done by or on the gas in the process? Was it done by or on the gas? So, whoops. Just gonna go back and then write for B. So the work done by the gas is the integral of P delta V. If for a constant pressure, that's just P delta V, where delta V is V final minus V initial. Since V final is less than V initial, then this is negative. And so therefore the work done by the gas is negative. Therefore the work done on the gas is positive. So there's work done on the gas. To sort of compress it. So maybe it's easiest to say that there is work done on the gas. Okay, so for C, Did the internal energy of the gas increase or decrease from A to B? Internal energy is always equal to 3/2 and RT. M stayed the same, R stayed the same, but T stayed the same. So yes, U did change. And then it particularly got smaller. So I'll say U decreased. Do DECR for decreased. And did he enter or leave the gas from A to B? How do you know? Okay, so D, to get the sign of Q, Q is equal to the internal energy plus the work done by the gas. So that's just rearranging it in its usual form, which is internal energy. U is equal to Q minus the work done by the gas. And then we can see that this, so I'll do this in a different color, maybe. So that's less than 0. And we already said that the work done by is less than 0. Therefore, we know that Q is also less than 0. So there it is.